Let's consider the high availability use case. In the high availability use case, it's also known as a fault-tolerant use case, a system needs to operate even though components of the system fail. So if you have 99.9% requirement of uptime, that gives you a maximum downtime of 8.76 hours in a year. Fundamentally, this requires your system to be redundant, requires backup applications to be able to start immediately, to take over a primary application fails. That's not just software, it's also hardware. You typically call these mission or safety critical systems and financially critical systems. So in these systems, you pretty much have to assume that any component or subsystem can and will eventually fail. So your usual approach is to make everything redundant. You identify some critical elements, either applications or processes. You identify hardware elements that are critical, servers, embedded targets, and also the network itself is a critical element. Now, having stated this, there are entire industries that provide solutions for failure detection, failover processing for these type of systems. DDS by itself is not a complete solution to provide or to implement fault tolerance or failover. It does have features, though, that could be very useful when you're trying to build such a system. So there are features within DDS that you will find useful if you're trying to build a fault tolerant system. High availability fault tolerance. Let's take a look at some features of DDS that can help you implement high availability fault tolerant systems. So first, quality service. Here's a couple of quality services, related quality services, ownership and ownership strength. And together, these can help you implement a failover policy so that you can identify an application as a primary application, identify one or more backup applications that can also serve or provide that information, and then set up a failover policy to be able to have the backup be able to take over when the primary crashes. Transport unicast, transport built-in, transport plugins. These are together a feature of DDS that allows you to configure how DDS uses the underlying transports. And transports isn't limited to IP. Of course, you could have IP, UDP IP, TCP IP, IPv4, IPv6, but you could also have shared memory. You could also have sending data over different IP networks. Some IP networks maybe it's Wi-Fi versus wired Ethernet versus a satellite link. You may have non-IP networks such as shared memory or perhaps a serial line. DDS allows you to use all of these different types of technologies and simultaneously. With these QSs, you basically can configure whether or not DDS is using these networks reliably, or DDS perhaps is just sending some of this data over one network and other data over another network. Finally, we have basically a feature. It's not a QS by itself, although there are some QSs that help you configure it. But there's a built-in feature to DDS that was introduced in Connext DDS 5.3. And it's called IP mobility, and it's very useful when you have dynamically changing network interfaces. So if you have a machine in which its network interfaces are changing as the machine is running, for example, you have a Android embedded processor that's on your car, and it's connected to 5G or 4G, and you're going from cell to cell to cell to cell, it's possible that your IP address to your car is changing. And IP mobility allows DDS to adapt and to continue to operate even though the underlying network interfaces are changing what are connected and as well as its IP address.